What's going on, guys? Welcome back to another example here. I'm gonna go through with this question. So first thing first, they're talking about half a revolution. Is 2 nanoseconds. That means it's only the half. If we're going for 1 revolution, it means a full circle. And that's 4 nanoseconds. And this is for the time. And from here, we can find the frequency of this charge of this electron. So we know the frequency is 1 over time, and this one is equal 1 over 4 nanoseconds. So the frequency equal 2.5 times 10^8 hertz. So we have the frequency. Second, we need to find the speed, the final speed that the electron is going, the final speed. The speed initial is 0. So we're going to use the energy formula, the kinetic energy formula plus the potential, the final, is going to equal the kinetic initial plus the potential initial. We know that the electron at the initial, at the start is 0. And the potential is 0. So what we are going to measure is the final kinetic energy and the final potential energy. So for this one, the potential is charge multiplied by the volt. Okay, so if we go from, so the mass of an electron is 9.11 times 10 minus 31 kilogram, and we're looking for the speed, for the velocity at the end, is going to be equal, we're just going to put this potential energy on the other side, and that's minus charge. It doesn't matter if it's negative, positive, we know that it's an electron, but we're just going to remove it from, we're just going to switch it on the other side. So the charge is multiplied by the volts. And this one is going to be equal to so 1.2 multiplied by 9.11 times 10 minus 31 kilogram multiplied by the final speed equal the charge, that's 1.6 times 10 minus 19 multiplied by 500 volts. So the speed, the velocity at the end is going to be equal to 1.3 times 10 7 meter second. Okay, and from here we can find the Biot-Savart law for the magnetic field. Okay, we need to find the Biot-Savart, and that's, we can use this formula for the cyclone motion. So the formula for the cyclotron motion is frequency equal charge, the magnetic force, the magnetic strength force formula divided by 2pm. So we know the frequency here is 2.5 times 10^8 equal the charge of electrons, that's 1.6 times 10 minus 19 multiplied by the Biot-Savart law. This one is the magnetic field strength divided by 2p, the mass of an electron, 9.11 times 10 minus 31 kilogram. And the magnetic field strength is going to be equal to 8.9 times 10 minus 3 Tesla. So now the question is asking us, what is the radius? We can find the radius by this formula, mass multiplied by velocity divided by charge multiplied the magnetic field. So radius is going to be equal 9.11 times 10 minus 31 kilogram multiplied by the velocity is 1.3 times 10 power 7 divided by the charge of an electron, that's 1.6 times 10 minus 19 multiplied by the magnetic field strength. That's 8.9 times 10 minus 3 Tesla. And the radius is going to be equal to 8 millimeter.